So let me ask the audience a question about this edition or this episode of Pipeline Things. Are steel sleeves, Type B steel sleeves, permanent? And are there conditions that can make them more or less permanent? When you install your Type B sleeves, do your procedures require the use of a filler material? Do they address the Bauschinger effect? If you are unsure what the Bauschinger effect means or the answer to those questions, this episode is the one for you. We bring on a previous esteemed guest and a close friend of ours as we take a look at the 2022 IPC paper, a comprehensive new look at Type B sleeves. Thank you for joining us on this episode of Pipeline Things. All right, new dance moves for those of you who are on our YouTube channel. Welcome to the IPC edition of Pipeline Things. I'm your host, Rhett Dotson, my co-host, Christopher De Leon. Super excited to be here with you as we join up. So, Chris, what's going on in life, man? How have you been?
It's fun. So, obviously, Mateo is in that phase where he's trying to get mobile. So, that's always fun in the De Leon household. And obviously, been a long time since we had started... I'm going to say childproofing our house, but...
Childproofing sucks, dude.
You know, we're not going to do that, but we're just trying to be careful with him, you know? And
by the time you get to 4, you just don't have that kind of energy. You're like, man, I can't put all this stuff up.
And I just remember, like, when we were buying stuff for some of our now older kids, we were real picky, like, ooh, let's get this stroller, and ooh, let's get this toy, or now it's just what is easiest, fastest, most efficient.
Amen.
It's unbelievable how you transition from, and some of our family members are having their first kid, and we're just sitting back watching them.
Yeah.
And they're still boiling bottles to sanitize them and using all these, and I'm just, dude, faucet water, put it in there, shake it up, give it to the kid.
I know that feel, man. I definitely know that
But
feel.
we're sleeping a little bit now. So yeah, it's awesome. He's all smiles. So he's brought a lot of joy and life back into the daily.
He does seem all smiles. You guys tell me how he doesn't sleep, and every time I see the kid, he's all smiles, man.
He sleeps when he wants. We just don't sleep. How about you, brother? You've been traveling a little bit.
Man, I have. It's been so you know, my family did a real nice summer vacation through California. That is a gorgeous state.
Yeah.
And we had a chance to see 4 national parks.
Did you go to Yosemite?
We went to Yosemite, was one of them.
Yeah,
we
Yosemite's
went to
incredible.
Muir Woods, Pinnacles, which is actually the least visited national park out there. And we went to Sequoia National Park. And then we also did some time at the theme parks down in southern
So
California.
we have in common is, so we both have 4 kids.
Yeah.
So you take all 4 of your kids and Morgan with you to these national parks.
Yeah.
Where it's not AC'd. You probably don't have a snack pack.
No. So we do come prepared in that regard, Chris. We're
Okay.
pretty, as not. We're not adept hikers. My family is fairly limited to under 3 miles, 750 feet of elevation change. I know their limits quite well. And but we went to Pinnacle, and so California has been in like a crazy heat wave. Like one point we were driving down to go to, I think it was Sequoia, and it was 112 degrees on the car thermometer, right? So
nice.
California's been quite warm, and outside of the coast.
So I know when you were
warm.
traveling, so mine was indexing 104, so you guys were on us.
Yeah, so it's a funny thing, while we were traveling, it was, one day I pulled it up, and Cyprus had the exact same temperature where we were. They were both 98 degrees. The difference is it felt like 98 in California. So it was 98 feels like 98, and it was 98 feels like 108 in Cyprus. So I can say unequivocally the heat is worse here, and we endured it worse. But we had some fun times. In Pinnacles, it got pretty hot with my family, and we actually went through a cave in Pinnacles. That's the only point where everything kind of broke down. So we were prepared. We had headlamps. I had some flashlights. But it was a bit closed, and you had to scramble up some rocks to get out of it with some tight spaces. My third child, Reese, stood up and hit her head, and she starts crying. And I'm like, look, keep going. The light's up there. And I mean, it was a good scramble. Like, it was decent.
So I have to mention something. So obviously, Rhett and I, our family's talking. So they send us this picture of his whole family in front of this massive redwood. And the only thing I could think about, other than super cute, is one time we were disc golfing over on TC Gesture, and they have these little like gnome doors in houses on the disc golf course, all I could think of was like, oh my God, this looks like one of those gnome decorations.
I will say the redwoods were fantastic.
That would be brilliant if somebody painted like a door over one of those openings.
Yeah, the age of those they're majestic, man. I mean, you're dealing with trees that are sometimes over 2,000 years old, and just being near something that's that ancient, that's that tall, it's humbling. Like you realize, like, okay, I've been here like 42 years.
It makes me think, let's not screw this up.
That is exactly right.
Like don't just leave it alone, right? Leave it alone. It's doing fine. It almost makes you think it's kind of like they're permanent if you don't screw it up, is kind of the way I think about it.
Yeah. And even then they're not, they're not totally permanent. They fall over. Climate change, again, whether you believe it or not, is actually impacting a lot of the redwoods. How well the mist comes in off of the California coast impacts them. How much rain they do or don't get. It's all really impacts. So they are permanent. And then it's actually, so many people might not be aware, the advent of the national parks actually came about in part because of what happened in Buffalo, Niagara Falls, as well as what actually happened with the redwoods. So at one point in time, they were harvesting all the redwood trees, and the public outcry in the late 1800s, early 1900s, where people were like, you cannot cut down these majestic trees for wood, and they were destroying the forest. So humanity absolutely has the ability to wreck those. But that subject of permanency, that's an interesting thing, because that actually kind of ties into our guest. And so I'm going to go ahead and introduce our guest. He's not been a permanent fixture on the podcast. I do think he's been a permanent fixture in our career, which is interesting.
Well, not in our career. Well, maybe.
He's had some permanency. I mean, look, he's been with me since like 11 or 12 or something like that. I mean, I've known him for a better part of a decade. Okay. And he has been a guest on the podcast before, but it's been a while.
Yeah, but I feel like you could remove it. Like, you kind of think of like something, if you wanted to cut it off, you could. Like,
so we cut off his access to the podcast? Absolutely. 100% right. I agree. But yeah, I'm going to bring him back on. So our guest today is Mr. David Futch.
Welcome.
David, it's good to see you again. So we bring on David. He was
Futchy.
He was the author of the IPC 22P paper entitled "A Comprehensive New Look at Type B Sleeves." And so, hey, welcome aboard. It's good to have you back, David.
Appreciate it.
Do you want to give, some of our audience may have joined since the last time. We've actually gotten a lot of new listeners. Probably since the last time that you were here. They might have started actually because you weren't on, but that's
probably it.
I have a feeling they probably don't. They probably don't go back and like.
I know. So can you tell the audience just a little bit? Who are you?
Yeah, thank you. David Futch. My background is a materials engineer, metallurgist. Do all things failure analysis, mechanical testing, welding, you name it, which takes me into a lot of repair stuff, because with any repair, you're adding material to a piece of material and hoping to improve its properties.
So, during the SAGE series, we had Dr. Dave Johnson on, who is a metallurgist. And he told us unequivocally that what you should do anytime you have a question for metallurgists is to ask a one-armed metallurgist.
Yeah, you only get one answer.
Exactly. You can't say on the one hand or the other. You subscribe to this?
Yeah, I mean, you should put 3 or 4 of us in a room and you'll get at least double the opinions. It's amazing. It's like rabbits. They just multiply.
Which answer is the right one?
The one I get.
That's what I thought, man. Well done.
Exactly.
So
he didn't say depends. So yeah.
I like he confident. Yeah. He's like my answer.
When we first met him, everything was depends. Yeah. Now he's like, it's me.
Yeah. So hey,
brought to you by David Futch.
We selected your paper because I really like the topic that you took on, and I think it's something that's not. I want to say I don't think it's discussed enough in our industry, David. So I want to come right out and I want to ask you a question: is a Type B sleeve repair permanent? Yes or no? Or are you going to say it depends?
Right? I mean,
there it goes.
In the context of a Type B sleeve, yes, it's permanent. But there are a lot of other factors that go into the install and the design and the considerations when putting one of these on that may impact its permanency.
You said something interesting. I don't know that felt like almost like a platitude. In the context of a Type B repair, it's permanent. What is that? What do you mean there?
So if the Type B sleeve is put on in a proper manner, right? Put on, repaired the feature with proper lengths and proper considerations on how you weld it on. If you give it the best chance to be permanent, then yeah, you consider it permanent.
So philosophically, maybe Chris, let me throw this question at you. And audience, I would like you guys to be thinking about this same question. Sure. What is, philosophically, Chris, as an operator,
sure,
what is permanent?
I think every operator have their own opinion. I'm prefacing it a little bit by saying some people would probably go to code and say, what does code say? I think from a practical perspective, I would say I set it and forget it. It's not something I'm monitoring anymore. That's one perspective I would have, right? So if I think of the integrity process, I'm assessing, I'm evaluating, and then I'm either mitigating or repairing, right? And so if I say I'm going and repairing this, often you would think if I put a sleeve on it, it's permanently repaired. I'm forgetting about it. So if I get an ILI, I'm actually using that as a marker saying this feature's repaired. It's done.
I don't need to track it. Don't need to do anything. I just need to know it's there. It'll be found in ILI.
I mean, even when you think about the response, I mean, we're ILI guys, right? When you think of response, you think of those things that are immediates. For example, things that have a near critical risk component to it that you want to go investigate. You have scheduled, which means, hey, it's probably not critical now, but it could get there at some point that I want to get to it. And then the third bucket, oftentimes they're called monitored. It's like they're not a condition. Often fatigue type issues might be there, where you're like, hey, I know I have something here, maybe like a lack of fusion in the gas line. Like, I just want to monitor it.
So Futch, what say you? To Chris's description of permanency, what's your answer around type B sleeves in light of kind of what Chris said? What do you think? Did you actually listen to what he said? I don't know if you did or not.
I did. No, I think that's correct. So it's what Chris described was you're properly putting on a type B sleeve. Right?
Properly putting on.
So if you properly put one on and you install it with the best intent, then you consider it permanent.
Install it with the best intent or the best practices? Because I might install something with the best intent, but totally messed
best
up.
practices. That's fair.
Okay,
yes.
Cool. So, and to catch the audience up, if you get a chance to look at the IPC paper, they covered a variety of I'm going to say maybe common questions that would arise in type B sleeves. So I'll give them to you so that you don't have to refer to them off of memory, Futch. But they investigated a few things, such as how does sleeve fit up impact the expectancy or permanency? Let's use that word, the permanency of a type B sleeve. If you do a groove in the back of the type B sleeves, does that influence the permanency of the repair? They also investigated the Bauschinger effect and whether or not that influences the quality of the repair. And then I will save the best for last, which is the filler material. Does your choice or inclusion of a filler material impact the permanency of a type B sleeve? So again, I want to pause in the audience. I want you guys to consider that. If y'all have repair procedures out there, stop and think for a moment around, do your repair procedures address any of those questions? Does it address fit up? Does it address whether or not you're required to have a filler material? Does it address things like the groove on the backing strip? And while you're thinking about that, I just want you to think, we're going to get into now, turn it back to Futch. Futch, give us a little picture of those four variables. Let's start with whichever one you want. Let's start with sleeve fit up. What did you find about sleeve fit up that you can share with the audience?
Yeah, so any repair, whether it's type B or something else, right? Any repair works due to the offloading of stress from the pipe, from the carrier pipe into the repair method, right? Obviously, the better fit you have between the pipe and your repair of choice, in this case, a steel sleeve, the better fit up between those two, you allow a more perfect offloading of stress into the sleeve.
So a transfer of load from your, let's say, imperfect pipe to whatever your, what I'm saying, I wanted to say damage, but that's not right. Yeah. Your pipe with a defect or pipe containing a feature. You need to load transfer from that pipe into your repair.
Correct. Yeah, and so you're dealing with, in that case, two imperfect circles, right? The pipe is a circle, but it's not going to be perfectly round. There's going to be some variation. It might be minor, but there might be some variation. And your steel sleeve is manufactured by some method, right? There's multiple methods to make them. It's also an imperfect circle. So you're putting two imperfect circles together. At some place they'll touch, and at some place they probably won't touch. So what's the impact of the fit up if it's imperfect to where you leave more of the area, quote unquote, untouched? How does that impact the ability of that sleeve to, let's say, remain leak tight for some given period of time?
Chris, is this something you felt like you saw? I mean, your days as an operator, did you deal a lot with fit up in the field, or did you get a lot of pushback people on fit up?
Maybe the pushback that I got wasn't maybe tied to fit up. If we're going to get super practical, a lot of times there's a division of effort. And so if, let's call it, you were the integrity engineer, you might call the repair type based on the flaw. right? So let's say, again, I focus primarily on gas. Let's say I'm on the gas side. I would have said, hey, let me go to B31 8S, maybe the 2004 version, because that's what's incorporated by reference. And there's a table, and you would go in there and say, hey, I have this kind of flaw. Here's the repair types I should consider, right? And so if it's maybe just external corrosion, maybe I thought of just a type A. If it was potential cracking mechanism that went across a seam, maybe I thought type B. And so often those are the decisions that I made, but all the things that we find in this paper were normally things that you would have to be qualified for to understand are in an engineering standard. But then a lot of times I just get held off to the field, right? Or to a contractor where you would give them your engineering standards and they would meet your specifications. And so you would assume, I will say that all the things that Futch brings to light in this paper have been addressed. I mean, you're kind of, unfortunately, kind of assuming that, right? You call a repair and then someone else ultimately is qualified for ensuring that the repair is done properly.
So what did you find about fit up, Futch? What advice do you have? And what were your findings on fit up? Is fit up a critical variable as it pertains to type B sleeves?
Yeah, so the tighter and the better fit up between the two, the longer life extension you have of both the underlying feature and the sleeve itself. So you've got two failure modes going on. You have the feature that you chose to repair, it somehow growing or propagating into the annulus space.
Mm-hmm.
And then once the annulus space is pressurized, you have the life of that newly formed vessel,
Yep.
right? And what the life is there as it continues operation.
So you get a leak path that grows from the original carrier pipe into your annulus and then progresses through the welds in the annulus ultimately.
Correct.
And your conclusion in the paper is the better the fit up, the better the life expectancy of the sleeve overall.
Correct.
Now let me ask you a question, because we're talking about in general terms. What is good fit up? Well, what's poor fit up in the context of the study? What's good and what's bad?
Yeah, so in the study, it was done with a varying forming method to create one that was tighter than the other. Now, I think you could exaggerate that and say a poorly fitting sleeve is one that doesn't touch the pipe anywhere, right? Is that conceptually possible? No, probably not, right? But I think the fit up where it matters the most is where the feature is and the areas around where that feature is. That's where the fit up is most needed, because that's where the stress needs to offload the most, allowing you to sort of impact that feature below it.
Gotcha. All right, second variable you talked about in there. So we're going to circle back around to this because I'm going to ask you for some practical guidance to our listeners. But what about the groove? So explain a little bit what you meant there, because I actually had to read it. I was like, what do you mean by this?
Yeah, so a mill groove is a commonly installed portion of the sleeve. It's basically a recessed area running along the long seam, the longitudinal part of the sleeves. You've one on either side. It's just a recessed area that holds the backing strip in place. Or provides area for the backing strip to stay in place, right? It doesn't physically hold it back. You often tack it to the sleeve, but neither here nor there. But the backing strip itself is meant to provide or reduce the risk of burn through when you're welding the longitudinal seams, providing an air gap and a constant air gap to prevent contacting the carrier pipe. So when you create that mill groove, you're obviously removing material. And if those mill grooves aren't installed properly, you could be leaving stress concentrators back at the corners, where if it's too sharp. So if the mill groove is installed with rounded corners and with a typical amount of wall removal, it doesn't necessarily impact the fatigue life of the sleeve. However, it's pretty common practice to consider that drop in thickness, the 16th or an 1/8 of an inch that's removed, as part of your pressure calculations to make sure you chose the right grade sleeve that you're putting.
Now, what if you don't do a mill groove at all? Because that's what you considered in the paper, right? It was mill groove versus no mill groove. Correct?
Yeah, but it was mill groove versus no mill groove in a purely cyclic environment, right? But we never took it to just burst it. Conceptually, you could think that, yeah, I've removed, a 16th or an 1/8 of an inch for 10 feet long. That's going to impact the burst properties, right?
Gotcha.
Does it impact it a lot? Probably.
You're saying it would impact it negatively if you had the mill groove in there. I'm understanding that correct, right?
It would have impacted it negatively from a purely pressure standpoint.
From a pressure
because
standpoint.
It's a source of wall.
What did you find about the cyclic side?
The cyclic, it largely inconsequential.
Inconsequential. So is it fair for me to sum that up and say, from a mill groove perspective, by putting the mill groove in, you conceivably could lower the ultimate burst pressure of the sleeve as a whole, but you gain no benefit on the cyclic side?
I'm not sure I would say benefit.
Well, let me ask you a question. Would you mill groove your
Yes,
sleeves?
I would,
Why?
because it provides a relief for the backing strip to sit in.
Mm.
Otherwise, when you go through the process of fit up, that mill groove can shift or fall out of place, creating a scenario where now you've put the welder at risk of burning through.
Got you. But from an integrity standpoint on the performance of the sleeve, no real impact, at least
Correct.
in your test. So it has more to do with, let's say, constructability,
Fair.
less to do with physical pipe integrity of the
That's
sleeve.
right. Yep.
Okay. All right. And we're going to run through these because, again, I think the last one is the one that's probably most important. The third one you mentioned was the Bauschinger effect. So I got to admit, I've heard the term Bauschinger effect thrown around in finite element circles as it relates to materials. It really surprised me when I came across this in your paper. Like I was almost scratching my head. I mean, let's test. Chris, do you know what the Bauschinger effect is?
Nope.
Can you spell it?
Probably not.
Miss. All right, here we go. Miss Producer, how many times have you used the word Bauschinger effect in your conversations this past week?
Not including y'all's?
Yeah. Never. Okay. Yeah. So most people. So will you please catch us up? What are you talking about, Futch?
Yeah, so Bauschinger effect is the effect when you load a piece of material in one direction and unload it in the opposite direction. It results in a lowering of the yield strength. So let's walk through that, right? If you had a piece of pipe that's already formed into a round shape, and you flatten that piece of pipe out to create a tensile test, the tensile test is going to test lower in yield strength than what it would have if it was still round, because you've worked the material into a round shape and then back into a flat shape. You've worked it in a direction opposite of what it was previously worked.
So what does that matter for sleeves?
So for steel sleeves, you're purchasing, or the vendor of choice, whoever you use, is purchasing flat plate that is then rolled into a sleeve, right? Gotcha. However, the tensile tests are typically performed on the flat plate prior to it being rolled into a sleeve, right? And so you have a coil of material that's been worked, uncoiled, and then worked again. And if those directions line up, you could be in a scenario where you've artificially lowered the yield strength of the sleeve itself when it's in the round.
I mean, on paper, I can see the argument.
Non-metallurgical material, are often all these processes always temperature controlled, so they're heated before formed, or is any of this stuff done?
It's cold, or it's room temp, whatever.
Well, that's what I was asking. Yeah. So a lot of times they're not heated, they're not heat treated. There's no heat application before they're formed.
That's correct.
So it's cold work to think about it.
Yes.
Yeah, that's interesting. This is learn something new.
There you go.
Thanks, Futchy.
So
I'm sure a ton of people just learned something as well
about the Bauschinger effect, the flattening and rolling and unflattening, flattening, rolling, and flattening again of the pipe material, or rolling and then flattening and then re-rolling of the pipe material. Got it. Yeah. And so, what did you find in your study? What impact does this have on let's say the usability or performance of type B sleeves?
Yeah, so we did tensils in various stages of the process. There was a drop in the yield strength, but it was minimal. I think in the paper it's somewhere around 3,500 psi on a grade 50. So it's not a large amount, and typically that's covered because you're not going to go out if you want grade 50 plate. You're not going to buy a piece of plate that's 50,001 psi. Mm-hmm. The manufacturer is going to produce it over spec anyway, and then the Bauschinger effect is largely inconsequential, right? It's within the tolerances of how the plate's machined or manufactured.
Okay. All right. And so before we go on to our next section, and I promise I think the discussion on filler material is probably going to be the most entertaining for our audience. We're actually going to pause, take a real quick break, and we're going to come back and pick up our conversation on the permanency of type B repair sleeves with the Futch Man. All right, welcome back from the break, where we are continuing our conversation on the IPC 2022 paper by David Futch, a comprehensive new look at type B sleeves. And we've covered 3 of the issues that you looked at pertaining to, let's say, the permanency of type B sleeves. The 4th one is bar none my favorite, which is why I saved it for the audience to the end, and hopefully you've hung out with us. And that is the influence of filler material. So this is actually a subject close to my own heart. I mean, going back, we were looking at this with Chris and I and Ali Eska back in 2000 and I want to say like 12, 13 time frame when I was at Stress Engineering Services, and I'm fairly certain that Chris did a paper on it back in like around that time frame. And you found very similar results, but I still think the industry is somewhat, I feel like, naive on this, Futch. So tell me a little bit about what it is that when we talk about filler material, what did you test in this program?
Yeah, so it was a dent with and without filler material repaired with a type B sleeve.
Right. And so to catch the audience up, well, I mean, really give us the baby. What did you find?
That the use of filler material extends the life of the underlying feature going into the annulus space. So it would extend the life of the sleeve system as a whole. So,
and I want to set the stage because I want the audience, we talked about permanency, and Chris, I asked you about permanency. Yep. We don't often think about sleeves, type B sleeves, becoming defects and failing. But Futch, what you're describing right there is a failure mode in type B sleeves. So i.e., I repair a dent, fire and forget, I'm done. I don't have to worry about it. But what you're saying is that if there is no annulus, no filler material, the underlying feature can eventually fail into the annulus, and then the sleeve, which is then pressurized, now experiences the pressure cycles of the pipe, and the circumferential welds on the end of the sleeve
or the long seam
weld will fail. Right. So I want to give the audience some of the numbers from to help them understand.
The key that we got to make sure we qualify that at some point in time.
At some point in time, which means it is not permanent.
But it is permanent.
It's permanent for a little while.
Is it permanent?
That's a negative.
It depends how you operate the line.
Well, what is permanent?
So let's discuss
that's kind of what we're getting to, right?
Let's discuss it. So if I do no repair whatsoever, I leave my dent alone, you found failure in about 23,000 cycles. Okay. If I repair it with no filler material, I get to 40,000 cycles. So that's about twice as long, right? But let's talk about the context of dents in pipelines. If a dent in a pipeline goes 50 years, you're saying maybe I get to 100. So if this is a construction-related dent, maybe I go from 50 to 100 years, right? Chris, I don't think permanent is 100 years. Not in pipelines that are currently 80 to 90 years.
It's permanent in my career.
It's permanent in your career.
And your career.
Well, that's a good way to look at it. But in terms of the environment and where this pipeline might be for future generations, it's not permanent.
Do you have any idea how many times I heard that before?
That's sequoia tree?
Hey, this is not my problem. You're the new engineer. This is your problem.
As stewards of the industry, that sequoia tree I talked about is still going to be around if that failure happens.
It is permanent if you leave it alone.
So, but if you put a filler material, you then actually got to a runout condition, which is at least greater than 100,000 cycles. And in the context, again, I want the audience to hear this. In the context of actually measuring the strain on the pipe, what you found is that by including a filler material, you effectively negated the stress concentration effect of the dent itself. So I'm going to state that in more layman's terms. You essentially made the dent behave equivalent to plain pipe, as though there were no stress concentrator there. I would argue that's closer to permanency than having a certainly no filler material in there. So a little bit, I want to give you the floor a little bit, Futch. Why is that, and how significant do you feel about the role of filler material in dents?
Yeah, so all the numbers you quoted was the amount of cycles for it to go into the annulus space, right? There is then some period of time additional that it takes for the sleeve to form and create a leak, right? So it's not double if going from unrepaired to reinforced without filler. It's double plus a bit more time because the sleeve is providing some
but
benefit.
That extra life of the sleeve is going to be, we know from experience that the weld quality and some of the issues of the circumferential or the longitudinal welds, they can exhibit very short lives once that annulus gets pressurized.
Correct. And so that's the wild card in it all, is what's the quality of the welds. I think everyone sets out to make a good quality weld, but welding is done by a human, and natural things done by humans can have issues, right? And so in that case,
so if you reduce the number of welds, you potentially are reducing the risk associated with the repair.
Where the number of welds come from?
Well, how do you get less than 3 welds?
Well, it just depends, right?
2 circumferential welds and a longitudinal, or 4, 2 longitudinals.
Well, maybe type B versus type A.
Ooh.
That's a whole nother.
So a type A can only be type. That is it's a fair question to bring up at the end.
Sorry, move on. Continue.
But yeah, so help the audience understand the importance of filler material and then the weld quality, in your opinion.
Yeah, so the filler material is done at the time before you put the sleeve on, right? It's a 2-part epoxy or something to that effect. It's hardenable. Added to the feature, sleeve put on. It's a pretty quick and easy process to do when the ditch is open and you're there making the repair. But as the numbers showed, it more than doubled, right? And we don't know what the end point was, but it more than doubled the life of that feature going into the annual space.
Chris, regulatory question. Filler material required?
I have to look it up. Can't recall.
I think Futch knows the answer, but I was really trying to throw you a bone. I mean, I give you a chance to really demonstrate your knowledge to the audience. And
on repairs. There you go. On repairs. Demonstrate your knowledge on repairs.
Futch, or do you know if filler material is required?
Yeah, so it's required for pressure reinforcing repairs, such as a type A or a composite or something of that nature. It's recommended but not required for those that are pressure containing.
Recommended but not required. So basically not required. Let's just cut it. Like, it can be recommended all at once, but people don't always take recommendations. They take regulations.
Correct.
Yeah, I think maybe I'll answer that differently, right? So maybe it's not whether the filler material is required or not, but rather I think it's more that decision process of what type of repair will I make for a threat that we think is on the pipeline due to ILI, right? And I think that is a different discussion, which is not the topic of today, right? But I think part of the so what of this paper, Futch, that I think you were trying to achieve, and we didn't really get to that yet, is I would ask, Futch, why'd you even feel like you had to look into type A's?
Type
Right?
B's.
Type B's, forgive me.
Yeah.
Right. And the reason why I say it is because often that is what the integrity engineer may or may not be challenged with, or the construction manager, the operations manager is like, why am I not using a composite? Well, we need to understand that. Why am I not using a type A? We need to understand it. Why are we not using a type B? And I think you guys did a great job in this paper of saying, let's look at type B's.
Yeah.
And why is it that we think the things that we do?
So type B sleeves have been used for over 50 years, right? Yep. And so the use of them and the process to put them on is largely taken for granted.
Yeah.
Right? Oh, I've done that for 50 years, no big deal.
Mm-hmm.
And so some of the newer repairs, like a composite or something like that, has gotten a lot of attention and a lot of research money because they're new and they're novel and people trying to figure out the limits. But a type B sleeve was investigated and studied back in the 60s. And then everything else going forward, it's just been normalized, right?
Sure.
We've been doing it for 50 years. And so the intent of this paper was to go back and look at some of the other factors and the differences between, let's say, an A and a B, and just put some numbers to it of if you were going to sit down and write a type B sleeve install procedure, what do you include in it, right? Is it a backing groove or a mill groove, yes or no? Is it filler when you're working on a dent or external corrosion, yes or no?
And how do these things fail?
Exactly.
Right. Reduce the risk of failure as much as possible. Hence,
right.
Groove or no groove.
I think it's a good question though, because I don't think it's, again, we're talking about filler material like it's a given. I want to point out it's recommended, not required, which means if you have a young integrity engineer that's facing a decision and somebody calls them from the field and says, hey, are we putting filler material in this?
Yeah.
Well, it's going to take us a little bit extra time. It's going to be some cost. Which filler material do you want? The young engineer's response might be, well, why would I put a filler material in there?
If they're a metallurgist, they can say it depends.
You say it depends, you're right. Or they might say, well, regulatory, again, economically, a large corporation might say, dude, we can save $2,000 on every repair by not doing a filler material. Let's not do filler material. But the consequences, as your testing have shown, are significant for the performance of a filler material. Let me state it another way. Futch, in your professional opinion, would you install a type B sleeve without filler material?
Maybe.
Why? Really?
So,
why?
He didn't use depends.
I know he said maybe. Now cares what condition.
Well, so it depends what the feature itself is and whether or not that feature is one that's susceptible to growing due to fatigue.
Why would you ever install if you're in the unknown? Why would you ever install it without?
That's fair. Yeah. If in all cases, I would put it on with, right? But there are some cases where
it may not make a difference.
It may not make a difference. And if I don't have it in the ditch or someone can't get it fast enough, maybe it's okay.
Yeah.
Right?
Yeah. So I want to go back to something, right? So we talked about fit up, right? You're like, look, fit up is super important, right? So you can transfer the load.
That's right.
From what I'm going to call the anomaly, or now you've discovered it, the flaw, the imperfection. We're not going to call it a defect yet. And if you can have that transfer of stress, effectively removing the stress concentrator, you increase the longevity of the flaw, right? Well, if you don't have a great fit up, then you need the filler material, right?
Correct.
The filler material now serves as like fill the gap, right? Fill the void, right? And serve as that transfer.
Yep.
I hear you saying fatigue, right? Be a little bit more explicit. How does fatigue play a role in that, whether I have a filler material or not?
Yeah, so back to the original point, all repairs, type B sleeve or other, work by offloading the stress of the pipe into the repair, right? And so it's especially important when you're starting to cycle. If you have an area or a gap, let's just say a crack. If you have an area or a gap where the crack is not seeing the offloading of stress to the sleeve, say you have a slight depression or a flat spot or something else that has some considerable length, that area, yes, it's reinforced because the surrounding of it is seeing some protection, but you're still going to get stresses to go to the crack tip.
So at the end of the day, there's still stress concentration.
That's right.
However, the stress that it experiences is reduced, therefore extending the life.
Because you stiffen the area around.
So this is not permanent, period. It's time dependent.
By,
I cannot forget it.
I
cannot set it and forget it.
By using a filler, you push towards the.
You can make it someone else's problem.
That's
you might outlive the sequoia
It
tree.
is permanent in my professional career.
In the next person's professional career. I mean, these are important questions, but Futch, I'm going to give you the floor a little bit. In your professional opinion, based off this research work you're done, somebody comes to you and says, Futch, what do I need to do to make my type B sleeves as good as they can possibly be? Last as long as they practically can. Boil it down.
That's not the right question.
No, it is.
That's
What
not.
is it?
That is not what someone's not going to come to him and ask that.
They're not gonna say
They're going to
that.
say, Futch, how do I make my type B's permanent? That's going to be what
All
they
right.
ask.
There you go, Futch.
Futch, how do I make my
B
type B's
sleeves
permanent?
Can you make my type B sleeves?
Oh, stop changing the question.
So many questions. So I would. I think you have to let's not consider any of the welding associated because that's a whole.
Well,
nother
you mean
topic.
the circumferential welds and the long
and the
seam
long
welds.
seams,
And
right?
the quality of the wool.
Right. Let's set that aside because that should be governed by maybe a welding engineer, your WPSs, what welders you choose to put in the field. That's a whole nother.
So feedback one is there's a whole set of issues you need to address
The
in
quality
other
of the weld.
research
Yes.
and make sure, which is the welds.
The quality of the weld
aside.
matters. Absolutely.
Okay.
So if you're
So the most important thing we're not going to address in this
Yeah, but that's
episode.
not trivial.
cool.
For the record,
No, it's
that's
not.
already the first nugget. It's like you want permanent type B's, get your welding down.
Exactly.
Point one.
Yeah. And welding with using the research and making sure it's safe and you have all the right safeguards when you're making the weld and all that, right?
Yeah.
But if you take that out, then the features that have a chance to grow or change, I would absolutely use filler material.
Any thoughts on, and then again, would you lump the groove and fit up and Bauschinger effect into things that you should try to make those good, but not critical, maybe less critical than filler and the other ones?
Yeah, so the filler is a void makeup, right? So if you can't get good fit up, you should use filler, right? Sure. And so the two, I think, in my mind, work hand in hand. And so some scenarios, a pumpkin, an oversized sleeve, an armadillo sleeve, something where you're purposely standing the sleeve off the pipe. Mm-hmm. Those scenarios are ones where you may consider some sort of grouted annulus or some sort of local filler in the area where you have some coverage.
Yeah, and it'd be important there, you have to use grout rather than necessarily just an epoxy, because if you mix a 5-gallon bucket of epoxy, you might light it on fire.
Well, it's something that's pumped in, right? That might be a mixable epoxy. It may be a concrete base.
Not recommended to be just epoxy. Based off of experience, you totally can light a 5-gallon bucket of epoxy on fire if people aren't aware of that. So let's talk a little bit about the future. Well, what's in the future for Futch in terms of this research? Are you continuing to do research on steel sleeves? Do you have anything coming down the pipe in 2024?
Yeah, we did some additional work with varying the amount of fill. That's not in this paper. It was presented at PPEM. Where we actually stood the pipe off the sleeve and then used filler in order to fill the annulus space. The results are very in line with what we talked about with this. However, I think the results are actually a little more alarming. It shows that the differences between the two are pretty large, especially when you're dealing with lower toughness older pipe.
Okay. Excellent. All right. Well, I want to say, Futch, thanks for joining us. It's good to have you back again. Are we going to see you at IPC this year? Do you have any publications?
Yeah. I'll be there.
Absolutely. Do you have a publication you want to share with the audience? Tell them to attend. This is your chance.
None of them have been formally approved yet.
Oh, sorry.
But yeah, I will be there. I got 2 papers, so hopefully we can talk more about those later.
Excellent. Fantastic. Well, hey, I want to thank the audience for joining us on this conversation on our IPC, looking at a comprehensive new look at Type B sleeves. And we look forward to hearing some of from our other guests in this IPC arc. And we look forward to seeing you in 2 weeks. Thanks.